The first was, am I going to credit Jesus as the creator instead of crediting natural processes, i.e. crediting the creation itself with creating? And so that was the first domino to fall. And what did that lead me to? Okay, he gets credit for creation, but then I thought, but the world is billions of years old, and that's really not negotiable, is it? And I went back to the Bible, and it really has no hint of these eons, but I thought it doesn't matter what the Bible says because science has proven it. And so then, over a course of, like 3 or 4 years, I wrestled with that question. Is the earth really like 6,000 years old? Because that's just unthinkable. In fact, it's laughable in my circles. And so if I were to come out and say, yeah, guys, I believe the earth is, less than 10,000 years old, they would go, okay, you're not our friend anymore. And who wants to not be someone's friend anymore? But I want to equip you to be able to face that day, okay? And are you going to go with what the crowd says because the crowd says it? Or are you going to go with what God says? And so, and it may take, I also want to equip you this morning in our next few minutes together. If you do take the recent creation approach, the biblical creation perspective, like I do, then you're gonna meet people who might want to listen to you, might want to listen to that perspective, and they might be somewhere on that journey like I was. But I'm telling you, it's like turning the Titanic. And it's like, really? Really? What's the evidence for recent creation? I mean, and how could all these scientists be wrong? And all these questions have to be answered along the way in order to turn the ship around. But ultimately, so what I'm saying is my goal is to persuade you if I can, but also to equip you to be able to have some tools to have those conversations with folks who might want to listen to an alternate view, a more biblical view that's based on one of my new favorite verses. It says something like this in Isaiah 66. This is the person upon whom I will look, he who is lowly and contrite and who trembles at my word. Does that describe you? Have you submitted your thoughts and your life, everything to him, lowly and contrite? Lord, you're in control. You tell me what to think. You tell me how to react. You tell me how to live. You tell me what to believe about the past. You fill me. And trembling at his word. I'm so thankful to be here among people who would say that. And I think that's why you're here. You're either here because you want to learn from the Word of God and be renewed in your spirit, or you're here because you're escaping something and you committed a crime and you're like, I'll just run away to this conference so I won't get caught. But now you're stuck with people who love the Lord. And now you're stuck with me, and I'm saying, hey, I really do think that science supports the idea that the Bible gives us that the world is thousands and not billions of years old. So let's just run through some of the scientific evidences. I'll try to explain these. Some of them are going to be kind of like, I didn't get what you're saying. And that's okay, because other people will get what I'm saying, because they have more of a background in that area. We're going to go from small to large, from micro to macro, as we look at these different evidences. And there are many more than these, but it took me being exposed to these kinds of evidences that I'm about to present for me to finally turn that ship around and go, okay, God, you got it right all along, not only about the fact of creation, but about the details of creation, like you created the way you said you did. He spoke and it stood firm, Psalm 33. And you created when you said you did. For in 6 days the Lord made the heavens, the earth, the seas, and everything that's in them, resting on the seventh day, Exodus 20, verse 11. And now I can say with confidence, even in the face of my colleagues who say, you believe what? And I've done it. And I just smile and say, this is what I believe. And I've got reasons for it, and I'm happy to take your questions. And I'm happy to even offer questions to you. Why do you believe in the old earth position? Why do you believe that this is that old or that's that old. What led you to that conclusion? You know, that's a great tactic to have, in our tool belts when we get into conversation. This is radically different. I mean, thousands versus billions? Are you kidding me? Someone's got the story completely wrong, and someone has the story, you know, which one are we going to go with? So to have a conversation with someone who believes something that's fundamentally different, very different, it takes Christians being the ones willing to build the bridge. How do we build bridges and have conversations about areas over which we disagree so strongly? And I think the tactic is Socratic. And so, Socrates gets credit for the question-asking tactic. What led you to that conclusion? What do you mean by that? Those are kind of the questions that we want to deploy. He gets the credit in our culture, but if you read the Gospels, you'll see Jesus deploying the Socratic method all over the place. Whose inscription is on the coin? Okay, well, give to Caesar what is Caesar's and give to God what is God's, which is your whole heart. That's what he deserves. So we want to do that. We want to become adept, not only at the knowledge, like evidence for recent creation, which we're going to cover, but also what I've done there is as we go through this, we're going to look at how to deploy that knowledge in conversation by asking specific questions, and just let the question simmer. That's what started me. That's what started me on this voyage of maybe doubting what I had been taught and told all my life, and maybe this Bible has something right. It was because someone asked me a question. They said, have you, I think I already shared this with you guys, but can you refute the idea that they use circular reasoning to assign ages to these fossils? And that was, he put it to me as a question, and I felt like I owed him an answer. And I thought at first, of course they don't use circular reasoning. They use experiments. He goes, what experiments? Well, let me go find out. And I went and found out that they don't use experiments. They use assumptions. Well, anyway, so let's start with our first realm or category of evidences for recent creation, and it is within our own bodies, within humankind. And so we're going to look at some genetics, and I'll try to make this pretty plain. Looking at world population growth, looking at world history, we see most recently here from 1300 up to around 2000. That's the time at which I grabbed all these data. It's time for an update, isn't it? Now, the blue line, I do have several graphs and I think one or two formulae in this, but mostly I just have pictures. So let's get the graphs over first because, you know, we eat our broccoli before we have our Oreos. So the blue line shows the actual population growth in world history there. And so we're having this population growth explosion lately, but because I think there's only 2 or 3 countries in the world that actually have a population growth rate right now that exceeds the replacement rate. So mom and dad, you got to at least replace those. So moms and dads need to at least have 2 kids just to have a replacement rate. But it looks like throughout human history we've had more than replacement rate, and it's about 4%. 0.4% population growth. So the 0.4% growth is based on history. It's like going back to the Roman censuses. Is that the plural for census? Plural for censii. How many? Anyway, they counted the number of people back in the Roman times, and then so this includes the death rate, birth rate, living up to the time of your life when you can have kids. It's about 0.4%. That's a historically responsible number. And anyway, so we can use a formula to describe the population growth rate, and it's pretty basic. The population at any given time is going to be equal to the starting population, or P naught, times the base of natural logarithms, which is 2.718, raised to the power of the rate times time. So P equals P naught times e to the RT. And if you plug in your historically responsible rate, 0.4% becomes 0.004 once you remove the percent. And then the time, you just plug in whatever time you want. So let's do some numbers. Our starting population, according to Peter, in both his books in the Bible, is 8. The 8 who were on the ark. So we'll just pop in the number 8 there as our starting population, or P naught. 0.4% growth rate, we know that. And we're going to type in 4,500 years as our estimate for the time, based on the Bible and human history, since Noah's flood. And that gives you, if you just plug that into that formula, it's a basic formula. You can make more complicated formulas, but this is close enough. You get 6.5 billion people by the year 2000, and it's really, really close to the actual number of people on Earth at the year 2000. And so that's about all you can get from these things is pretty close, but this is remarkably close. Now, the opposition, or the defender of evolutionary time, as I once was, has to then say, only in the last 4 or 5 millennia have people been, having a growth rate, population growth rate. Before then, there were eons, we're talking millions of years, of strictly replacement rates. So every family had 2 surviving kids, 2 kids, that's it, survived to become the next generation. And so it never grew for eons and eons and eons. That's a story. And it's kind of like, well, how did they never have population growth until recently? So they have to backfill their story with answers to that question. So if I were to extend the timeline backwards, I would have to suspend what we know about human history and suspend what we know about population growth historically, and we'd have to draw this imaginary line that would just go past the parking lot in the evolutionary, to support evolutionary time. And if that were the case, ultimately I can ask this question: where are all the caskets? Where are all the bones from all those hundreds of thousands, and even millions of years of people who had this magically precise, strictly replacement rate, population growth of 0.0000 for eons? Instead, I think it's more responsible scientifically to just go with what history shows, and that is human history has been around for about several thousand years, 4,500 years, and it gives us really close to exactly the population that we have now that we would base on the Bible. So I can reduce that to a question. So if you're taking notes, jot down these questions and deploy these questions in conversation. And I would love to hear stories in the future of, hey, I was asking, and you're gonna run into bumps. It's gonna be bumpy conversations, but that's okay. Jump in and try, or you'll never learn. Hey, if mankind is millions of years old, as you're telling me, cousin Vinny, then why only just now do we have the billions of people on planet Earth? If we've been around for a long time, then why didn't we become billions a long, long, long time ago, eons ago? And then, of course, they may have an answer. And you may go, okay, that's a good answer. I didn't know there was an answer to that. And then you have to go back to ICR.org to study up why what they said is wrong. And there may be a level of back and forth and study that's required. But then the follow-up question would be, where are all their bones? If people have been around for so long, why only just now do we have billions? And where are all the bones and remains of all those people who have been around supposedly for that long? Because we only have remains from about as many people as we would expect since we got off the ark. Our ancestors got off the ark only 4,500 or so years ago. It's a good match with both the population growth and the number of human remains. Okay, so that's population growth. It fits the Bible's history. Pretty cool. I think it's cool. Because what do I do now? I go, oh, the Bible got it right. I don't have to worry about what scientists are saying against the Bible because they're ignoring these, pretty basic, pretty comprehensible results. What about genetics? We have this thing called mutations. So mutations are what? It's a copying errors in your DNA. And so here's a recent paper from the world of genetics. And what they have done is sequence the entire genome of 3 surviving generations. So we have grandma, ma, and then grandchild. And we have the whole genome sequence of each of these generations so that they can track and actually count. So there's 3 billion base pairs, in each of these genomes. And so of the 3 billion, how many mutations occur between generations? And what they found is it's right around 100. So 100 new mutations in this generation, and then grandchild has another 100 mutations or so in their set of genetic instructions. And so what that means is, guys, you're more of a mutant than your parents and your grandparents. Hey, we're all mutants, join the club. But what this means is there's no known mechanism to delete these copying errors. And so they just accumulate relentlessly. Most often, the vast majority of these copying errors, rare though they are, because 3 billion and you're only getting like 100, that's a high integrity copying system. And what I'm talking about is DNA polymerase, which is this giant enzyme complex that's copying the DNA inside mom's egg cell, inside dad's sperm cell. So you got to copy all that DNA, and it's such high integrity that you only get these few errors. But once you start accumulating these errors over multiple generations, it starts to manifest itself in different human diseases, okay, and in different other effects, like we're finally having lower and lower IQ. That just came out a few years ago. So IQ relates to accumulated mutations because your mental processors start to slow down due to garbled information. And anyway, so we have this software that Dr. John Sanford, who actually, his Titanic turned as well. He was a Cornell, a plant geneticist. He's famous for inventing this thing called the gene gun. And anyway, he started going to church because someone invited him to church. He was attending church, and then the pastor, he was attending church, didn't know Jesus, didn't have a relationship with God, but thought, well, I need to attend church because my wife wanted to, or some reason like that. And then they said, hey, you're a smart guy. Why don't you teach Sunday school? And so they started teaching Sunday school, and that forced him to read the Bible, where he learned that he's a sinner and needs a Savior. So he and his wife knelt beside their bed and trusted Christ, and they became Christians. And after that, then they started thinking about, okay, wait a minute. The Bible says something very different about where we came from, and he became one of our investigators into this concept of genetic entropy. Entropy, a measure or a description of things falling apart, always getting less and less organized overall. And it turns out that our own genomes as a human race are falling apart. And so anyway, we have this software that he's developed called Mendel's Accountant, after Gregor Mendel, and taking account of all the accumulated mutations. So let's just break this graph down a little bit. First of all, ignore the green. Okay, check, done. And follow the red. The red shows a decline in, if you look at the y-axis, it says the word fitness there. It's a bit arbitrary, but fitness of 1 is a theoretical expression of pristine DNA. By the way, at the end of chapter 1 of Genesis, what did God say about his whole creation? He checked it all out. He goes, whoa, this is very good, very good. Adam had pristine DNA. Eve had pristine DNA. By the way, that DNA that God crafted, handcrafted, he molded his body out of clay, then breathed into his nostrils the breath of life, and man became a living being. And the DNA that was in that body, in Adam's body, already had a whole lot of alleles or genetic options in it. And so that meant that because he had so many alleles that they could have many generations down the line, and every generation would produce somebody unique, somebody different, with different DNA. And that's why we all have uniquenesses and differences in this room, and we glorify God in that way. So he built that in, But the fitness level goes down as the mutations increase. See that? So because this red line goes down, our fitness is decreasing, and it's sort of an estimate of the integrity of the genome. It would be like this: you have an encyclopedia long instruction code on how to build, let's say, a skyscraper. I want to build a skyscraper. Well, I'm going to need 17,000 girders for the first floor. I'm going to need 40 million rivets. Whatever it is you need, you got to bring all the stuff in. I'm going to need a backhoe to do this and build the foundation, and then we'll need lots of glass windows, and so the instruction codes are there. So the instruction code includes the materials and what order those materials need to be aligned and brought in at what time, and placed this first, that second, and that third, so we can build a skyscraper. Similarly, you start with one cell inside mommy's womb, and that one cell has been given the code to build an entire body, arms, legs, fingernails, teeth, all from one cell. And so it's like more complicated than a skyscraper. But the rivets are really tiny. They're like proteins and individual little tiny pieces. And so but now, let's say you've got your encyclopedia and somebody tears out a page, or really you have to copy the encyclopedia. Let me change my analogy on the fly. You're copying your encyclopedia because you got to give it to the site supervisor, and you keep the home one here and you give the site supervisor another copy, but there's a copying error, and so you get one word messed up, or let's say you've got 3 billion words here, and 100 of them get garbled. Well, you can still figure out really what's going on, because you only have 100 differences, and you have the context of the rest of the text in order to backfill the little blanks. They're pretty meaningless. How many rivets? Well, it's close enough. It says 30,000, but we really only needed 27,000, so we had a few extra rivets, no big problem. But when you start to copy the next generation, and you get 100 more, and 100 more, and 100 more copying errors in your encyclopedia, you're going to end up with, according to this software, after about 320 generations, do you see this little tail end where it dives down? The red line dives down. We call that mutational meltdown. And at the given parameters that we plugged into this software, maintaining the population size at 2,000, every lady gets to have 6 children. Isn't that great, gals? Give me 6. We tried for 7, but then we had 5 within 4 years, and we were like, no, it's not 7. I had twins in there, so that makes that possible. And so, talk about a meltdown. Whew. So we say 300. We can estimate about 350 maybe if you twiddle the knobs. But the reason we want to give every girl, every mom 6 babies is so that you can cull through, the really mutated ones, and you can kill 3 of them. You can kill half of mom's kids, and let natural selection, which I don't think does anything, but let's just model it anyway. And so you can kill off the most mutated kids, and that'll help us survive longer. That's what the software allows you to do, using, for sake of argument, the reigning paradigm of how things are supposed to work. And anyway, so you can still have a population growth if, on average, you have more kids surviving. So you set the knobs and dials and buttons the way you want them. Anyway, if you have any realistic parameters at all, you're going to get mutational meltdown around 300, 350 at the most, really, generations. So if you have, generation time of 20 years, then humanity, today's measured mutation rate, which is about 100 per generation, we can live about 10,000 years, And so that puts so today's mutation rate puts about a 10,000 year shelf life on humanity before all of us start having stillbirths. And you know what? This is a sad news, isn't it? It's like, we're doomed. But you know what? We are doomed. And the gospel teaches us that. is appointed to man once to die, and after that to face judgment. And are you ready to face him? Do you anticipate getting to see him? Because you can, but you got to reach out to him now before it's too late. And guess what he's promised in his scripture? Behold, I will make all things new. He's going to make a new heavens and a new earth, and he's going to give us new bodies, glorified bodies, to fit the new heavens and the new earth. And that new place, those new bodies are no longer going to accumulate mutations. And it's going to fit together with this new heavens and the new earth, where righteousness dwells and where the effects of the curse have been lifted and suspended by the power of the Lord Jesus Christ, who made everything very good in the beginning and who will remake everything, not over the course of eons, but just like he did it the first time. He's going to say, you know what, I need a new heavens and a new earth, and I need it right now, and he's going to speak it into existence again, and it's going to come again. And he's going to give you, if you have trusted in Christ, and if you are in him, have a relationship with him, a new body. Okay, so last bit about mutations. The four creatures, 3 animals and humans, for which we have actual, realistic, measured mutation rates, show a consistent pattern, consistent with young earth creation predictions. So let's break this down. I have a simple bar graph. And the first is a roundworm. So let's look at box A, and this is work by Harvard molecular biologist Dr. Nathaniel Jeanson back when he was with us at ICR. He's since moved to Answers in Genesis, another creation organization. He's doing good work over there as well. And he says this. So mitochondrial DNA. Have you heard of that? Yeah, heard of that. So it's since no one's responding, I'll assume you're not heard of that. But it's like you've got your DNA that's in the nucleus of the cell, but then there's little annex, this little extra bit of DNA. It's like a loop of DNA. For humans, it's about, 17,500 base pairs long. It's a loop of DNA that lives over in your mitochondria because it needs to be there where you can manufacture the proteins that are required to process energy and build ATP, like we talked about yesterday. So anyway, this mitochondrial DNA is easier to sequence, it's easier to model, and it's easier to measure the decay, the mutation accumulation rate over many generations. So they've done this with roundworms. Everybody say, Caenorhabditis. Hey, now you're all officially biologists. Caenorhabditis is the roundworm, and there have been tons of studies on roundworms, these little roundworms, because you can grow them fast in a lab, you can feed them easy, and you could manipulate them in all kinds of different ways. So, but what the evolutionary model holds is that these creatures diverged from their most recent common ancestor, according to evolutionary theory, 18 million years ago. And during that time, at today's measured mutation rates, its mitochondrial DNA would have undergone something like 2,400,000 mutations, which, since it's only 17,000 bases long, that means the entire genome would have recycled. Every single base in that genome would have been mutated many times over that time span. And then we predict at today's measured decay rate, same decay rate, but using the creation model, let's say this creature has been around for only about 10,000 years. That's generous, because I think it's closer to 6,000. But over the course of 10,000 years, at today's measured rate, you'd expect something between 940 and 1781 mutations to have accumulated. And then we can actually measure the number of DNA differences between individuals in these worms. And what do we find? A number that is 1655. That's the actual number of DNA differences at the time this study was done between individuals that have been sequenced. Those genomes have been, mitochondrial genomes have been sequenced. And you see the exact fit? Do you see which model this fits? I mean, it's a dead ringer. This is a really strong prediction. So we've used the creation model of recent creation to predict only 1,000 to 1,700 mutations have occurred, given the mutation rate, assuming that today's rate that we measure is the same mutation rate that's been occurring in the past. Then we see the actual number of DNA differences matches what we predict based on the Bible straightforwardly taken. Same with Drosophila. Say that. I feel like I have to make you say stuff just to keep awake because this is so dry. It's like graphs at 8 in the morning. What are you doing, Dr. T? You're killing us. But what's okay? We're gonna eat our cookies in a minute. So after 20 million years, which is how long the evolutionary tale says that the fruit flies, these are fruit flies. You know, we've done lots of studies on fruit flies. And so there it is. The prediction after 10,000 is something like 1,000 DNA differences, and the actual fits very closely the predicted number of DNA differences based on the recent creation model. Same with Daphnia, which is these little water fleas. They're not fleas, but they're nicknamed water fleas. And it's a little copepod, or a little crustacean that lives in fresh water. It's called Daphnia. And you can see the creation prediction way down there. It's the blue bar. The bar is so short because the time is only 10,000 years. And then the actual number of DNA differences is 646, much closer to the creation prediction. And finally, you and me, humans. We've done the mutation rate, and then we've actually measured mitochondrial DNA differences among many, many people across the globe. And so we see DNA differences in the mitochondrial DNA averaging about 10, which is right in the range that we would predict based on the creation model. Okay, cool, huh? This is going to take another layer of paint for it to stick in our minds. So you got to dig it. You got to dig it out of ICR.org if you want to learn this one. But it's a fun one to know, and it's a fun one to learn, and you can turn this into a question. If mankind is millions of years old, as you say, my friend, or Uncle Vinny, then why do we only have thousands of years worth of mutational buildup? We do. Look, we only have thousands of years worth of mutational buildup, both in our nuclear genome as well as in our mitochondrial genome. Both genomes have only thousands of years worth of mutational buildup. And it looks like we were created recently, and we've been decaying ever since then. This is part of death, part of the death process. So not just creationist research, but evolutionists as well, like this guy Kondrashov, who asked this question back in 1995 when he was studying population genetics and mutational buildup. And he said this: why have we not died 100 times over? Does this make sense? He's assuming that we have been around on planet Earth for tens of thousands, yea, nay, millions of years. And so we should have accumulated so many mutations that we should have gone extinct 100 times over in all that evolutionary time. And he's trying to answer this question. But there's no good answer from the world of nature. The best answer is we just haven't been around that long. That's why we haven't gone extinct 100 times over. Okay, so we're done with humans. Are we happy? You are so thrilled. We're done with humans. Let's go to Earth. Recent creation of Earth. Evidence, scientific evidence that I learned, as I began to learn these from creation scientists that came before me, it really started to steer my Titanic back to believing the Bible and God's Word taken straightforwardly. Here's another one. Here I am back when I was young and handsome and looking at a road cut. So we have road cuts where we see beneath the earth, and we've got these rock layers. So these are limestone layers there in the Dallas area. It's the one hill that Dallas has. It's called Cedar Hill. And what am I pointing to? I'm pointing to a rock layer, limestone, that has clam shells in it. That's the most abundant fossil, is bivalves. Bivalves down below, bivalves up high, bivalves right here. So I'm looking at these. And so I was trained in my geology courses that this layer that's, say 3 feet thick, slowly accumulated. And so it's about 1,000 years per centimeter of slow settling silt that accumulated to build these layers. You've got to have a lot of time to get rocks this thick, is what I was taught. Then I began to learn from other sciences that you don't need a lot of time if you have a lot of water. And what does the Bible say about the world back then? A lot of water. Noah's Ark, Noah's flood, lots of water, lots of mud. And that mud, I think, buried these clams. But how do you get clams? I mean, how slow does a clam have to move? I know they move slow, But how slow do they have to move to where they get trapped by a sediment that accumulates at a rate of 1 centimeter every 1,000 years? That is one slow clam. He's having a bad day if he can't move a centimeter after 1,000 years. But these clams got trapped. How do I know? The valves are still together in many cases. So if you go to the beach and you see clam shells, are the valves, the shells, still together or separate? Yeah, they're usually separated. And it doesn't take but hours for a dead clam for its two valves to separate. It's less than a day maybe, because the little ligament that holds the two together gets eaten by bacteria and it gets etched by salt water today. And the wave action tumbles these things and they break the shells apart. So it's in order to see these clams with the valves still together, it shows that they were inundated, they were rapidly buried. So we see that in this layer and in most layers where you find clams. So I don't think that the 1,000 years per centimeter comes from any kind of scientific measurement or observation. It's just a backfilling of a belief. We got to have these rock layers accumulate slowly because we got to have our millions of years, because we got to believe in evolution, because the alternative is creation. We don't want that. And so it's sort of circular in its logic. So we asked the question, if one layer took thousands of years to form, then why does it even have fossils? To get a fossil, guys, you've got to bury the creature quickly. Bury it quickly. That's just step one in the recipe for fossil making. And so we can ask that question, why does it have fossils? And what I'm saying is, these are disarming because you want to ask your friend who disagrees with you, you want to ask them a question genuinely. Like you want to say, explain this to me. I really want to know what you think. But I'm thinking about this, and I'm like, how can it have fossils in it? Maybe you can explain this to me. How can it have fossils in it if it really took eons to form? Wouldn't the creature have degraded or been scavenged or rotted in the time that it took to form that so slowly? And it may be the first time that your friend or your uncle has ever heard a good question like this. And then they have to go back and answer it for themselves. And because you're genuinely curious. You're not approaching this conversation like, oh yeah, if one layer took thousands of years to form, then why does it have fossils? Like, no, that is not bridge building. That's wall building. That's not the approach. So it's not just the fact that we're asking a question, it's the way we ask the question that I want to advocate as well. And it's the care and love that goes with it that is critical. Care and love. Okay, and then the next question, let's look at this. What about So then geologists started telling, back in the late 80s, the 1980s, they started saying, well, look, there's evidence that the layer itself may have formed rapidly. And then the layer atop that may have formed rapidly as well. But we know we've got to squeeze the millions of years in here somewhere, so we think it's in that gap, or that time gap, that imaginary time gap, that happened between the layers. So in other words, now the story is, this layer formed rapidly, and then we wait millions of years. Finally, eons later, another layer lands on top. And so we're going to stick the time in the joints or the gaps between the layers. There's no gap, but anyway. Do you see any gaps? No. It's the line between the layers. So that's where they're now inserting time. If that were the case, what happens at Earth's surface if you wait eons? Is it going to stay flat and level and smooth and even? Not at all. Erosion happens. So they have to suspend rain for all those eons. Even a little rivulet would form. What we should have is the rock layers, if they're eons old, should look like this. Rifts, faults, cracks, stuff being filled in. It should look like a hot mess. It's already messy as it is, but these layers, so you've got a layer, and it looks like that layer was not there very long at all before the next layer went right on top of it, and the next, and the next, and the next. How do I know? Flat contacts, the flat contacts between layers. So, one layer looks recently deposited, the next one looks deposited right after that, and it looks like you've got this rapid sequence of deposition, which fits what we'd expect from the flood having taken only a year to deposit this whole rock stack. So we're looking at basic geology, and just applying logic to it, if millions of years occurred between each layer, then where are the ruts? Where are the valleys? Where are the chasms that should have been filled in when that new sediment came in and should have filled in those chasms? It's not there. It looks rapidly deposited. So here we are on the Buffalo River in Arkansas, and I'm canoeing with my kids when they were little and cute. And I'm looking at these layers of limestone, layer after layer after layer, and I'm appreciating the power of the flood, because you've got no gaps between these layers. And you do have clamshells and other marine fossils in these limestone layers exposed there along the shores of the Buffalo River. And so many places. There's no evidence of time. It looks like rapid deposition because it has fossils, and then it looks like rapid sequential deposition because there's no ruts between them. Okay? Now this one we've already talked about yesterday, but we have original proteins in these fossils, and those are another indicator of youth. Hemoglobin, keratin, of course, collagen. And so we reduce this to the question, if animals fossilized tens of millions of years ago, then why do they still have short-lived proteins and even whole tissues like blood vessels? And we looked at that yesterday. Here's another one I did not show you. It's a fossil frog. And what do they find? They find original bones. This is in Spain. This frog got caught in a volcanic explosion, and his body was partly carbonized, but his bones didn't get completely carbonized. And they opened up his femur bone, top right, and what do they find inside that femur bone? Blood, still colored red inside the femur. I don't think it's millions of years old at all. It can't be, because hemoglobin doesn't last that long. Just another example. This is from Tyrannosaurus rex, showed it to you yesterday. And if you look at insects in amber, it's another example of, there's nothing about amber, guys, that is magical, that can magically preserve whatever's in it. Amber doesn't do that. And over time, amber darkens, amber develops cracks. All it is tree resin that is hardened, and insects got trapped. I think a lot of this amber happened because tree branches got broken. Whole trunks, trees got broken, and so during the flood. And so you have all this tree resin oozing out, and creatures were walking around and trying to survive the flood and didn't, and they got trapped in that flood. And then the amber got buried with the logs, and you have these coal seams now with these flat-topped coal seams that have amber in certain parts of the coal seam. It got sorted by water action so that the amber floated to where its density matches. Anyway, we call it resinites. And most coal seams have resinites, and that's what these are. Some of them have insects, and even, like, there's one with a half a lizard in it. There's hairs and feathers in it. So these, I think these are remnants of the flood. Anyway, they found tissues inside the insects. So it looks recently deposited. The age assignments for some of these ambers, tens of millions of years. Well, then these insects should have turned into dust. The amber itself should have gone black and cracked, and everything in it would have been exposed to oxygen, and it just looks recent, looks a lot more recent. And then another one, if Earth lasted millions of years, then where did the carbon-14 come from that we find in fossils, coal, and even diamonds? So much background work has been done on this, paid for by ICR donors who want to see us explore and explain the evidence that supports biblical creation or recent creation. We have sent sample after sample of coal, fossil, even diamond to radiocarbon dating labs, not to get a radiocarbon age for it, but just to see, is there any radiocarbon left? Because the shelf life, or the half-life, I could say, of radiocarbon is, 7,530 or so years. Shelf life is fewer than 100,000 years, in theory. And so if it's younger than 100,000 years, it might still have radiocarbon in it. And we found radiocarbon in fossils, including dinosaur fossils, in coal. Coal assigned conventional ages of 240 million supposed years, and yet it has radiocarbon in it? Explain this to me. Where is this coming from? And they may have explanations, but at least lay it out there as a challenge. And there's some data that we have. They have to reconcile these data. All right, and even diamonds. Super cool. What about the fact that we have continents at all? Because we can measure the erosion rate of continents. And today's slow and gradual erosion it should have, over the course of millions of years, we shouldn't have any cliff sides. Cliffs erode even today. Rocks fall from cliffs. So you shouldn't see cliffs as you're driving around or hiking around. You should see rubble piles that go right up to the top. And the cliffs should have filled in, should have fallen down. In fact, we shouldn't have continents at all after 40 million years, and yet we're told that the Earth is billions of years old. We should have no continents left at today's erosion rates. But yet we have continents. If the Earth is billions of years old, then why do we still have continents? They should have eroded into the sea. We should live in a water world by now, if it's that old. And there's all kinds of science to back this up as well. But I'll just leave these with you as, basically, I got a lot here. So you pick your favorite. Just pick your one favorite and go research that one and make that a question that you can ask. So I'm going to give you a whole smorgasbord from which you can select your favorite scientific evidence. And we get to go to the solar system. Woohoo! Let's fly to outer space. This is my favorite comet. We sent a probe, European Space Agency sent a probe out there to investigate Comet Hartley 2 is the name of it, named after an astronomer. And not only is this comet, so what do? Comets, it's a ball of dust and ice, and it swings really close to the sun, and it has a very eccentric orbital pattern, close to the sun and then far, far away from the sun in this long, squished oval pattern. And every time it gets close to the sun, it gets so close that the sun burns off a lot of the material that makes up the comet, so that this is like a ticking time bomb. It's like another egg timer, and after so many passes by the sun, it just gets obliterated. And there's no comet left after that. Yet we have thousands and thousands of comets still in our solar system. But this one, Comet Hartley 2, not only is it falling apart because of its passing by the sun, but it's also emitting. You see these jets. These are jets of CO2 coming out. So something is pushing, energizing the jets, and it still has material that's able to be pushed out. This looks young. It does not look billions of years old. And so we can reduce it to a question. And by the way, just go to icr.org if this is your favorite one. Study this one out and just type in Hartley 2, enter. And then you'll learn all about Comet Hartley 2. And this might become your one of your favorite talking points or angles, wedges to use to ask a question. If the solar system is billions of years old, then why do we have short period comets at all? And why does Hartley 2 have jets that are still being emitted? We shouldn't have any short period comets. Shelf life on those is like 10,000 years based on how often they pass across the sun. And yet we have lots and lots of short period comets in our solar system. Our solar system really does look young. It looks recently created. What about Saturn? Ooh, so pretty. First time I saw Saturn in a telescope, I thought, I've seen pictures, but now I see with my own eyes. Awesome. And the rings are bright. You can even see them with binoculars, the Saturn's rings. Turns out those rings, if they're billions of years old, or hundreds of millions even, those rings should be dim, dark, and dusty, having accumulated dust. Space dust is a real thing. And so most of the particles that make up these rings are broken bits of ice. So dust should stick to the ice, and it should be dark, but it's not. It's bright and shiny as though it was made recently. A lot of the ice comes from ice particles that it may have been like moons that God created and have since been smushed and squashed, but it's razor thin. I mean, the particles that make up these rings, and there's moons embedded in these rings, and they're wobbling out of the flat plane of these rings. And so over time, the flatness of the rings should have expanded and randomized, but they're still super flat as well, and they're still super shiny. And I'm not telling you this because I've noticed it. I'm telling you this because secular, evolutionary, mainstream astronomers have asked this question, and they put it in the literature. Hey guys, we're looking at Saturn's rings, But they don't put it in your test books. They don't put it on TV programs like PBS Nova. They just ask among themselves these private little questions. So that's why we exist at the Institute for Creation Research. We read what they write to one another in these technical journal articles. And what are they asking? Why are Saturn's rings still so pristine? And we have an answer. It's because it was created recently, and it's only been accumulating dust for thousands of years, not for millions or hundreds of millions. Saturn even emits a lot of extra heat. Okay, so here's my question. I boil it down to this. After billions of years, shouldn't Saturn's rings look dirty? But they don't. That's how I've expressed it. You can study your own favorite evidence and then build your own question out of it. I encourage you to do that. How could Saturn still emit more heat than it receives? After all these billions of years, these planets should be old, cold, and dead, but they're not. They're like hot potatoes flinging around in space. This is the graphic that accompanied the news report. They expected, based on the age of this planet, a little bit of heat, but they observed many times more heat that it's emitting. I think it's still hot potato, because it's recently created. That's from Enceladus, one of the moons of Saturn. But Saturn itself has the same heat problem. Too much heat for it to be old, cold, and dead like evolutionary models would have it. By the way, solar system, and then this, and then the universe, and then we're done. We're almost there. You're doing great. Hanging in there with me. And I'm pretty much, I'm out of time. How about I just end with this one? You can look up the universe ones later. So this one, This one shows a graphic that someone made of Earth's magnetosphere, or magnetic field. So the Earth has a magnetic field, and it's part of what God built into our planet to protect us from otherwise harmful radiation that would come from the sun, solar particles and such. So you got to have the field strength at a certain strength in order to protect. And it turns out that the magnetic field of the Earth is decaying. It's decaying at a rate such that it loses half of its field strength every 700 years. And by the way, whichever evidence you select, this is going to be my favorite. I'm going to talk about this one when I have a conversation with a friend who's, of course the universe is millions of years old. And then you can ask him, what about the Earth's magnetic field? And if you want to use this one as your favorite, then look up the decay rate. Look up the actual decay rate. If it's human mutations, then you know the decay rate, 100 mutations per generation. This one, it loses half of its field strength every 700 years. So why do we still have a magnetic field after 10,000 years? It should have gone away, and we should all be completely irradiated and lying on our backs dead with our feet wiggling in the air. But it's not. So I think there's a hypothesis that I have based on the Bible, why the Earth's magnetic field still is strong enough to protect us from otherwise harmful radiation is because the Earth's not that old. That would explain these data as well. Really quickly, galaxies should have wound up. Spiral galaxies should have completely wound up in the time that evolutionists assigned to them, but they're still spiral. That's a question we can ask. We have globular clusters. I'm missing the R. Globular clusters. They have fast-flying neutron stars. They should have flown out of the globular clusters, given the age assignment to these space entities, but yet the globular clusters still have their fast-flying neutron stars are still within the globular cluster. They look recent as well. That's a young feature. And blue stars, we see them here, there, and everywhere. These are the SUVs of the universe. They burn through their fuel in a lickety-split. But there they are, blue stars. They have a max lifespan of something less than 1 million years, and yet the age assignment for these blue stars is billions of years. And so, of course, evolutionists propose star formation is what's supplying new blue stars all the time. And that's how we have recent blue stars in a really old universe. Problem being, no one's ever seen a new blue star turn on. So I think these are just blue stars that God made recently, and that's why they're still out there burning through their fuel super fast. Okay? Now we're actually done. Which kind of evidence works best for history? Experiments today, not the right tool. Eyewitness accounts, that's how we do history. And it turns out that the Bible itself, I've learned, is an eyewitness account. What did Peter say in 2 Peter 1? We were eyewitnesses of these things. We saw the Lord Jesus. And so God himself is the eyewitness, and he left us a record of what really happened. So I now am happy to report that science supports the idea that we can all build our world history based on the record that's in the Bible. The Bible itself is like a birth certificate for the universe, telling us when and how it was created. And with more and more confidence, I can say, and encourage you to say as well, Lord, I want you to look upon me because I am lowly and contrite, allowing you to inform me and not me telling you what you're supposed to have said in your book. And I tremble at your word. May that be true of all of us. Thanks.